Alec.
And I'm Anthony.
And this is our Project 2 implementation. As a general tour, here we have our MSP 430 control. This is our DAC board. Over here we have user input with the associated debounce circuitry. This is an audio amplifier to help characterize the sonic characteristics of each of our waves through the speaker. And this Arduino is just providing power, serving as a glorified voltage source. We'd like to start with our square wave. Heading over to the oscilloscope, as you can see, when initialized, our wave generator will produce a 100 Hz square wave with a 50% duty cycle. We can push the frequency button to cycle through frequencies, going to 200, 300, 400, 500, and back to 100 Hz. You can also cycle the duty cycle from 50, 60, 70, 80, 90, down to 10, and so on, incrementing by tens. You will also notice that the duty cycle is preserved across frequencies, so it is very robust. Coming back to our speaker, we can turn up the volume a little bit, and you can hear a general sample of how, for example, duty cycle affects the timbre of the wave, and how frequency affects the pitch of the wave. Moving on through our wave options, next we'll go on to our sawtooth wave. Once again, this wave has frequency options from 100, 200, 300, 400, and 500 Hz. Next we have our sine wave. This one's a little harder to hear, so we'll turn it up. This one also, as you might have guessed, has options from 100, 200, 300, 400, and 500 Hz. Our implementation also has a fourth wave. This wave is a combination of three individual sines added together to produce what we call a chord. By zooming out in time, we can see three sine waves added together.